Hi, this is Chris, and we are taking a look at questions 27 and 28 here in section 4 of SAT Practice Test 4. So, for question 27, they tell us that what we see depicted here in this figure, it says it's the relative housing cost for a U.S. city. They say it's defined to be the ratio of the average housing cost for the city over the national average housing cost, expressed as a percent. And those are the units that we see for each axis. So percent of national average cost here, and then population density here. So our percentage is a percentage out of the national average, and then they're showing this over population density for our x-axis. Okay, so let's take a look then at just the figure itself briefly so that we understand what this is. So this is a scatter plot where you have each of the individual data points represented, and then we have what we call a best fit line. So this is going to be a line that's supposed to show the trend in the data. So it basically is, when you talk about a best fit line, it's the best approximation of the individual data points that minimizes how far each data point is from the line. So you can see the line's going to go basically through or very close to most of the data points when you go to draw a best fit line. So that's what we're looking at here in this figure. And here in this description, it says the scatter plot above shows the relative housing cost and the population density for several large U.S. cities in the year 2005. The line of best fit is also shown and has this equation. Which of the following best explains how the number 61 in the equation relates to the scatter plot? So we see this here, and hopefully when we look at an equation like this, we want to see this and think to ourselves, hey, that's slope-intercept form. That's y equals mx plus b. So if this is slope-intercept form, then this is going to be our y-intercept at 61. And we want to talk about what that means. So if we're looking at that y value, we see on the axis it says percent of national average cost. So let's take a look at a couple of our answer choices here. For A, it says, all of these are in 2005. It says in 2005, the lowest housing cost in the United States was about $61 per month. Well, let's see if that's the units for that y-axis. Is it $61 per month? No, it should be 61% of the national average. So A is incorrect. Those are the wrong units. We don't have to evaluate that further. For B, it says it's the lowest housing cost in the United States was about 61% of the highest housing cost. Well, let's see. They say it's percent of the national average. So not percent of the highest, percent of the national average. So again, it's a little closer. At least it's in a percent, but that's not the correct unit for that y-axis. And then if we look at C and D, so we can see for both of these, they do say 61% of the national average. So we're at least talking about the right units here. Let's talk about the meaning of each. So for C, it says, even in cities with low population densities, housing costs were never below 61%. And for D, it says housing costs were likely at least 61%. So here, never is an absolute, likely is a little bit less severe. That just means that that's the likelihood, but not necessarily a must. So now let's talk about what your best fit line shows. And like we said at the beginning, your best fit line is your best approximation of the trend in the data. It does not show an absolute bottom or an absolute top, like end for that data. It's just your best approximation. So 61% is the approximation. Then could it be below 61%? It could. We can eliminate C. It's not never below. And the reason that it's D is that likely goes with your best fit. Your best fit line is the best approximation, or a likely representation of the trend in data. And your answer to question 27 here is going to be answer choice D. Now let's take a look at 28. And for this one, they say which of the following is an equivalent form of the function f above, in which the minimum value of f appears as a constant or coefficient. Okay, well, first things first, we want to make sure that it is, in fact, equivalent, which means it's got to be the same thing. So the easiest way to do that, since we see this done in our first few answer choices here, is that we can go ahead and multiply this out. Let's FOIL this and see what we would get. So here we do first outside, inside, last. So we're going to have x squared, outside terms, negative 4x, inside terms, positive 6x. And your last terms, a positive 6 times a negative 4 would be minus 24. Here we can combine like terms. So this is x squared plus 2x minus 24. And let's see if we can find anything that's equivalent. So A is definitely not equivalent because they're missing the plus 2x in the middle. B is equivalent. We don't know if it's showing the minimum value as a constant or coefficient. So, but we can say for B at least, let's keep it on the board because it is equivalent. Let's check C. So here if we FOIL out that first part, x squared minus x for outside terms minus x for inside terms plus 1 minus 21. Combining like terms, we'll get x squared minus 2x. We can already tell it's not going to work. Positive 1 and a negative 21 is minus 20. So that one is not equivalent. And then for D, here when we FOIL this, we get x squared plus x plus 1. And then minus 25. Combining like terms, here we get x squared plus 2x minus 24. Okay. So this one's also equivalent. So we weren't able to get the correct answer just from multiplying those out, but we were able to limit it down to just 2 answer choices. So that's pretty good in itself. That already gives us a 50-50 shot of getting 28, which is one of the more difficult multiple choice questions correct. And now let's take a look at this wording here. When they say minimum, and you'll see the wording for either minimum, maximum, or vertex. If you see any of those keywords, when they're asking you to come up with a particular form of a quadratic equation or a function where you see x squared terms. So here, when you see any of those words, you want to think vertex form. And our vertex form is y equals a times x minus h quantity squared plus k. And here your vertex is hk. And the reason that matches this idea of a maximum or a minimum is because whichever way your quadratic is facing, so if you have a parabola facing up or down, your vertex is going to be either that minimum or that maximum point right on that axis that goes through the center. So along that axis of symmetry, you have your vertex. And sometimes they will ask for the vertex outright, sometimes they will ask for the minimum, sometimes they'll ask for the maximum, but in all cases, what they really want to know is, can you put something into vertex form? And if we take a look here at answer choices B and D, both of those are equivalent, but only one